All right, here we're identifying the vertex of each parabola. You can see it as a graph in number 7, and you can see it as a table in number 9, and I'm going to show you how to identify it both ways. First, the vertex is the highest or lowest point, and just visually, if you look at number 7, you should be able to see that the highest point right there at the top, okay? So if that's the vertex point right there in the pink dot, then identifying the vertex requires you to identify the coordinates of that point. Remember, point is 2 coordinates in x and y, and so if you find yourself just saying a single number when identifying a point, that should be a key that you're not saying it right, because there is no point that's described by a single number. You always describe it with 2 numbers, unless you're saying something like the y-intercept, and when you're saying that, it's assumed that x is 0. But we still know what both of the values are. So if you don't know what the values are, there's no way to identify that point. So how do we identify this point? Well, as always, we start at the origin right there, and we go how many units left, right, the x direction, and we're going 2 units in the positive direction. So we've got positive 2 as our x coordinate. And then from there, how many units do we go up to get to the point? We go up 1, up 2, up 3. Going up in the y direction is positive. So the vertex is at 2, 3. Okay? Now, for number 9, what you need to understand for this is that there is symmetry around the vertex. Okay? So you can see here that for the y coordinate we get 2 and 2, 8 and 8. Whatever's right in the middle of that symmetry is going to be that vertex point. And this one is easy because it's identified as 2, 0. Okay? And there will be occasions, and you will get to them and you'll become familiar with them eventually, there will be occasions where you see something. Well, I guess I can just draw an example on the table just to make it clear what I'm talking about. If you had these values, let's count up from, let's say we've got -2, -1, 0, 1, 2, 3, and 4. And the y values are doing something like, let's say this, like 11, 5, 3, 1, and then again 1, 3, 5, and 11. We wouldn't get some middle number. You can see how there's got to be some number in here, right? Because if we're talking about the symmetry, we've got this symmetry, but what's the point that it's going around? It doesn't seem to be there's a point in between there. Well, what is in between there is going to be what you get when you plug in the exact middle in between that 1 and that 2. So you would say, okay, then the vertex point, since we see the symmetry happening there and we don't see that middle point, we know that it's going to be right in between there. So it's going to be 1.5, comma, because 1.5 exists right in there between 1 and 2. And then whatever you get when you type it in, when you plug in 1.5 to the equation, you actually have to calculate that. It's not going to be right in between 1 and 1 because they're the same number. So there's going to be a different number that's in there that you need to calculate by plugging this in. Okay? So sometimes on your table you won't see that perfect symmetry around an obvious point like we do in our in our table. Let me just get rid of all this and then I'll just reiterate it one more time. You're getting symmetry, and you can see here and here those numbers are the same, but there's a clear number that's in between them that's just a single value, and that's what we're choosing in this particular case. But sometimes you'll get something else that lands right in between 2 values. So anyway, if that's unclear to you, my apologies, and come ask me about that. But the last thing we need to do is we need to identify if this is a maximum or a minimum for each one of these. So, oops. So let me get these marks out of here real quick. Those marks. And let's take a look at these numbers, because what's happening here is you can see that these y values are getting lower and lower until they bottom out at 0, and then they start going back up again. Okay? So if you ever see the y values dropping until that vertex point and then going up again, then that means that this is a minimum. Okay? And the minimum y value that you get is 0. So this is going to be a minimum. And again, if you understand it conceptually, you understand what's going on there when you're plotting those points, it's going to be easier. On number 7, you can see that clearly that's a maximum because it doesn't get higher than that, and when you have a highest point, that's what's called a maximum. Okay? How do you identify a maximum or a minimum on the table? Just like I said, you're going to see, if you see the numbers dropping until they reach the lowest point and then start going up again, that means a minimum. Okay, good luck.